Welcome to a slow, beginner-friendly lesson on raising exceptions and finally in Python, made for absolute beginners. Throw and clean up. Last lessons we learned to read exceptions and to catch them with try and except. Today we turn it around, we learn to raise our own exceptions when the input is wrong, and we learn the finally block, code that runs no matter what, success or failure. We also meet the else block, which runs only when the try succeeded. Together these four keywords, try, except, else, finally, give you complete control over what your program does when things go right and when they go wrong. 4 keywords, full control. Here is the project for this lesson. A folder called raising_finally. Inside, pyproject.toml. Under src, a same named folder holding main.py. A tests folder for later. The shape is identical to the last 2 lessons. Once you know where main.py lives, you can find it in every project from here on. The standard shape. Create the project with UV init raising_finally. Move in with CD. We do not need runtime libraries here, but we add PyTest as a development dependency with --dev. UV writes the project file and creates a locked virtual environment automatically. Every command from here on goes through UV run, which manages the environment for you. One command. To run the project, edit src/raising_finally/main.py. Save it. Then in the terminal type UV run python-m raising_finally.main. The -m flag runs the module as a script. UV run takes care of the virtual environment. To run tests later, type UV run pytest. The same edit, save, run loop you practiced before. Edit, save, run, raise lets you throw your own exception. You decide the type and the message. Raise your own. Recap so far. Try and accept catch exceptions raised somewhere else. Today we learn to raise our own. The raise keyword lets you throw an exception on purpose, with a type and a message you choose. We also meet 2 new blocks. Finally runs no matter what, perfect for cleanup. Else runs only when the try block succeeded. 4 keywords, full control over error handling. From catching to throwing, here is the simplest use of raise. A function called divide checks whether b is 0. If it is, we raise 0 division error with a clear message, b cannot be 0. Python would have raised this same exception when it tried the division, but raising it ourselves lets us give a clearer message and lets us check the problem before any work happens. Raise is how a function says, I refuse to continue with this input. Refuse to continue. You can raise any exception type, with any message you like. Here setAge checks that value is an int, if not, raise type error with a clear message. Then it checks the value is not negative, if it is, raise value error. The caller can catch the specific type and show the message to the user. Good messages are short, specific, and tell the caller exactly what went wrong. Bad messages, like just the word error, help no one. Clear messages, validate input at the gate. Refuse bad data with a clear, named exception. Check at the gate. Here is the validate pattern in full. A function parses the text to int, then checks the number is between 0 and 100. If not, it raises value error with a message that includes the bad number. The caller wraps the call and try and accept value error as E, and prints bad input : and the message. The function refuses to return a bad value. The caller never sees a crash. The user gets a clear, specific message. This is how robust programs are built. Validate early. Here is the full picture. Python runs the try block first. If no exception happens, the else block runs, then the finally block runs. If an exception does happen and an except matches, the except block runs, then finally runs. If no except matches, finally still runs before Python passes the exception up. Notice, finally always runs. That is what makes it the right place for cleanup, closing files, releasing locks, printing a done message. All 4 blocks, the finally block runs no matter what happens in the try. If the try succeeded, finally runs after it. If an except ran, finally runs after the except. If no except matched and the exception is about to escape, finally still runs first. That guarantee makes finally the right home for cleanup, closing a file, releasing a lock, disconnecting from a database, printing a final message. Code that must run goes in finally. Always runs. Here is finally in action. We open a file, then enter a try. Inside try we read the file and print the character count. The finally block closes the file and prints file closed. Whether the read worked or raised, the close always happens. In modern Python you would usually use the with statement for files. It closes automatically, but finally is the general tool you will use for resources that with does not cover. Close the file. Finally always runs, success or failure. It is where cleanup lives. Sweep up. The else block runs only when the try block finished without raising anything. Its job is to keep the happy path separate from the plan B. Instead of putting more code inside try, where an exception from that extra code would also be caught, you put it in else. That way only the truly risky line is watched, and the code that depends on it lives in else. Then finally still runs. Read it as, try this, if it worked, do this, if it failed, do this, and always do this last. Happy path only. Here is else in context. We try to parse the input. If it fails, the except body prints not a number. If it succeeds, the else body runs, you entered, and doubled. The finally body always prints done. Notice the two print lines that depend on n live in else, not in try. That way, if those lines threw an exception, it would not be swallowed by the except value error. The happy path stays separate from the recovery. Separate the paths. Here is the cleanup pattern. We open a file, enter a try, and return the first line. The finally block closes the file. Even though return exits the function, finally still runs first, Python guarantees it. So the file is always closed, even when we return from inside the try. This is the pattern you will use for any resource that needs cleanup. Open it, try to use it, finally clean it up. The with statement does this for files automatically, but the pattern is worth knowing in full. Resource safety. Good messages matter. Look at this transfer function. If amount is negative, raise value error with the exact rule. If amount exceeds balance, raise value error with both numbers in the message. The caller can catch, log, or show the message to the user, and the message actually tells them what to fix. Bad messages like just raise value error help no one. Spend 10 extra seconds writing a clear message. Your future self and your users will thank you. Help future you. Here are all 4 blocks in one example. We try to parse the user's age. If they typed hello, the except value error body runs, please type a whole number. If they typed a number, the else body runs, next year, age +1. The finally body always runs, input step finished. 4 blocks, 4 roles. Try is the risk. Except is the recovery. Else is the happy continuation. Finally is the always cleanup. Most real error handling uses only the blocks it needs. All 4 together. Sometimes you want to catch an exception, do something, log it, print a note, and then let it keep going. Use the bare raise keyword inside an except body to re-raise the same exception. Here we print logging : and the message, then raise. The exception continues upward, eventually halting the program or being caught by an outer try. Finally still runs first, attempt finished. This pattern is common in libraries. Log the problem, then let the caller decide what to do. Log and pass on. Quick self-check. Can you write raise value error with a custom message? Can you explain why finally is the right place for cleanup? Can you describe the difference between else and the code that just sits at the end of try? Can you re-raise an exception after logging it? If any feels shaky, re-watch the matching part. Raise, finally, and else are the missing pieces of full error handling. Say each out loud. In one breath, the raise keyword lets you throw your own exception with a type and a message you choose, the foundation of the validate input pattern. The finally block always runs, success or failure, put cleanup there. The else block runs only on success, put the happy continuation there. And the bare raise keyword inside except re-throws the same exception so an outer caller can also handle it. 4 blocks, full control. 4 blocks, full control. Next lesson we step back from exceptions to one of the most famous patterns in Python. If __name _ equals ___ main ____ . You have probably seen it at the bottom of Python files. We learn what __name _ actually is, what the pattern does, and why it lets the same file work as both a script and an importable module. It appears in almost every real Python project. Name main next. Thanks for learning raise and finally. Next we meet the name main pattern. Throw and clean up.